Hello, everyone. Welcome to the Meet the Young Professional webinar series, where we are from the IEEE Bangladesh section's Young Professional Affinity Group. Each week or twice each week, we try to introduce the young professionals who were once a part of the IEEE Bangladesh section and then left for his or her career to another country, and then to share with us their current field of research or field of work and give us career advice or advice related to research. So I'm really happy today to introduce Dr. Rajib Mikail. So Dr. Rajib Mikail sir is actually one of my direct classroom teachers. So he taught me microprocessor and interfacing when I was an undergraduate student at BUET, Bangladesh University of Engineering and Technology. Then he actually left for his PhD, and right now he is working as a senior scientist at ABB Corporation, USA. So Dr. Mikail completed his BSc and MSc from Electrical and Electronic Engineering from Bangladesh University of Engineering and Technology. Then he did his PhD from North Carolina State University, and currently he's a senior scientist at the US Corporate Research Center of ABB. So his research interests include motor drives, electrical machines, robotics, and automotive powertrain systems. So without further ado, let's hear from Dr. Rajib Mikail for his talk.
Oh, okay, everyone. Do you hear me? Is my sound clear? Sajid?
Yes, you're audible. Sorry.
Okay, nice. Hello, everyone. Welcome to today's talk on future of energy energy and automation. Let me share my screen and make sure that it is clear.
Yes, it is.
Okay. Okay, first of all, thanks to Sajid and also IEEE Bangladesh section for arranging this. I hope the time spent here will be worth spending. I will try my best. So outcome of this talk is, I would say, motivation first for research, and also enough information, those who are interested in doing research in the area of automotive and aviation, drivetrain, powertrain, machines and drives, power electronics, and also IoT related to all these fields. So at the end, I will also talk about like you need a lot of motivation and determination to do research or any field. So that is one off topic will be how to keep motivated. So I think that is very important because it's a long time that you will be spending from your life for research. You need to have enough motivation and sustainable motivation to continue that. Okay. So in this area of research, there are three fundamental categories. One is the fundamental science, and under that, there are research on solid state devices, mainly for high power devices. And then also theories and topologies, so which will be under the fundamental category. Then there come research on enabling technologies, like energy management, grid interface, distributed energy storage, solid state transformer. And then finally, there are also research in the demonstration side, like large scale simulation or large scale hardware in the loop experiment, or full scale hardware implementation. So it is. Hello.
Yes.
Just stop and I can stop answer. So in research, depends on like which category you will be working on. First of all, it depends on your interest. Do you feel more comfortable in the solid state physics side? Then you can do research on that side also. Or do you like an actual hardware implementation? Like you just take a device that is made out of this research, and also you may also use some of these elements of this research, and then you don't need to know all the details of this research. You just use that in a demonstration. And all of these stages need research. It's not straightforward. It needs research. So then I will go to each of them a little bit. So if, let's say, if you want to do research on the devices side, so there is a huge hype now, and also there are lots of incentive on doing research on wide bandgap devices. Basically because these devices, for example, silicon carbide, gallium nitride, is currently people are spending time to boost its capabilities in temperature and also voltage, and also the another important aspect of is, even though you operate at higher voltage, higher current, these devices are taking less energy, or it is overall system efficiency is higher. So that is one aspect of it, the research. You can develop these kind of devices. You can also work on the control theory, because whenever you change your operating frequency, especially whenever you go to higher frequency, there are lots of challenges that needs to be overcome. So the control theory and topologies that you know from your textbook or your undergraduate, that also needs to be revisited, or there are research opportunities there also. And material science is also another aspect of it, which mostly the materials people do research, and energy storage is another, like a battery, that is also a material science kind of, or chemical science. So those who are doing research on the battery technology, that is also under this umbrella of research. So this is basically showing all different steps of like what it takes from the beginning to the end. At the first, it starts with wafer level. You just develop the devices. You just focus on this research. There are another research is packaging of these devices. There is another research that people do, and lots of challenges, thermal, low inductance issue, and many challenges there that needs to be solved. The other aspect is, like I said before, let's say someone already developed it, you just build a converter based on that, and do some, you can show the benefits and efficiency benefits and other benefits of these devices that can be applicable to many applications. And this is a final system. Once a device has passed all these stages, then you can, like it has to pass all these research. And then finally, you can do research on how to implement it on a large scale, like a solar inverter, a hybrid car, data center, medical imaging. Here I will talk about the center that is very famous in this area, is Future Renewable Electric Energy Delivery and Management System, in short, FREEDOM. It is a center in North Carolina State University, and they have 30 plus faculties. I also graduated from this center, and we are proud to say that we have the inventor of IGBT, Jayant Baliga, here as a professor. And also some of you may already know that the Professor Iqbal Hussain, who is also from BUET, is the director of this center. Yeah, so that is very good for us. We are very proud of that. And I mean, all these, what I mentioned just in few slides back, all these kind of research are actually done here also. And there are centers like these, National Science Foundation funded, like government funded centers in all over the US in different universities. This is just one of the example. Okay, so now I'll talk about why it is so important. So visually, I can show you just one example. The first reason because people are so interested on these is they want to go to high switching frequency and also achieve higher efficiency. So what are the benefits we can get out of it? As you can see here, just to give you an example, a 50 kilowatt solar inverter, if you use conventional silicon-based technology, it will weigh about 380 pounds, okay? But if you use these new technologies, new devices, the weight of the same performance, with same performance, it comes down to 51 pounds, around 50 pounds. So that means there is a huge reduction in installation and other costs. And also, like, if you have a 380 pounds, then you need more people to handle it. You need lots of space, and also the cost, also a huge thing. So the business model, almost all applications, they see that there is a clear benefit of using these devices. Even if these devices cost more for temporarily, they are willing to go for it because of other benefits. And this is just to show that, like, just snapshot from different research, thermal and application related. And this is also showing one of the goal. For example, research here in US is driven, one of the driving factor is the goal set by the US Department of Energy, DOE. For each year, they have a goal for particular applications. And because of this, all these research, we are actually ahead of this. So whatever goal they set, it is realistic and it is achievable within this time. And this is a very good driving factor to shoot for. So now I will talk about little about machines. Almost all applications has motors and drives, and research on motors also need to continue in the same pace, because if you reduce your power electronics and other system reduction, you need to also improve the power density or efficiency of the machines also. So these are all different types of topologies of machines. Each of them are good for particular applications. Not good for all applications, but depending on the applications, the topologies, some topologies are suitable. So, and then people do more research on how to make it more efficient and more longer lasting. So this is one slide from one of the student from BUET who is doing research here in Freedom Center. His name is Shariful Islam. He's from BUET 06 batch. He's currently doing research on next generation lightweight motor for unmanned aerial vehicle and drones applications. You see this um, for this kind of application, the weight is a factor. So the highest priority of this research goal is the volumetric and mass specific power density and also torque density. So he's doing research on this with Dr. Hussain, and I'm also advising him on this. So I could show you something on this. So this one is showing there is a huge potential for going for rare earth free topologies. Rare earth free means there are magnets mainly used in the machines which uses rare earth materials. But because these materials are not readily available or only available to some specific countries, so there is a problem of pricing. So if it is when the demand goes high, machines using these kind of materials become very expensive. So now there is not now actually for a long time there is a huge incentive for research, both funded from government and industry, on rare earth free topologies. So this slide is basically from my PhD, my whole 5 years of work in just one slide. I hope not you will understand everything, but I'm just putting some snapshot. So there are electromagnetic, structural controls, different aspects of things that people need to work on. One revolution that is going on right now is the robotic automation. So industrial robots and collaborative robots, as you can see here. Collaborative means robots working side by side with human, and you can trust the robot that you can work with them. So there is a huge revolution going on right now. Robots are also working in the industry. Those are pre-programmed to do a specific task. So the research on robotics is mainly also the same that goes in the aerial vehicle, because the robot needs to do more like lift more payload, and also the robot has to low cost, and also the robot has to be lightweight. So that cannot be done without research. So there are lots of research on that also. So these are different aspects of it people are working on. The biggest incentive for robot is for the business motivation is basically one robot can actually replace 5 workers, so which is huge. And a robot, it will just do whatever you want them to do. So if you just do some initial investment, all the electronics and automotive industries are now moving towards fully automated manufacturing. The research aspect of robot is we are not very familiar of industrial robots, or like what are the research aspects, but all these previous slides that we talked about, all of them are applicable in this application also. But this is a very difficult or more high performance applications where accuracy and precision is the toughest goal to achieve. For an industrial robot, to reach to any, like there are boundaries where it can reach to, as you can see, if you see from this view, if you see from top view. So this is the boundary it can reach. And in order to do that, it is made of a 6-axis system. And each of these axes has one motor, one drive, and one gearbox. So that means there are 6 motors, 6 drives, and 6 gearbox. So in this case, the gearbox and the motor are here, but the drives can be somewhere else. Or if it is a collaborative robot or even lightweight smaller robot, the drives can be also sitting somewhere in the robot. So now the question is, the research question is how to make it lighter weight and achieve the same payload, same accuracy. Like for example, in this case, the robot has to reach to a particular position. Millions of times it has to go to the same position with a millimeter accuracy. And it will work like that for years. And you have 6 motors, 6 gearboxes and drives, which is the toughest and I would say the difficult application where a motor drive application has ever seen, which requires a very high precision to achieve actually. So there are lots of research on this and all these big companies are working on now. The next is revolution that is coming is the also research is going on is the autonomous aerial vehicle. I already had one slide on one of the students from Kuwait is already working on motors for this application, and companies are now doing research on like safety, how to make it more lightweight, and also there are research on the batteries. If it is a battery powered, then it has to be lightweight also. And also how to come up with a system design that will make sure the range of the system is longer, like it can go to higher distance for the same design. Future of clean transportation. Right now, you know, there is 2 potential technologies that will eventually take over for clean transportation of future. One is the battery system, which primarily uses lithium-ion battery right now, and the other one is the hydrogen fuel cell system. But what we see is the battery system is picking up mainly because of the infrastructure. It has already lots of charging stations are installed.
सोहाग भाई मासूम भाई their friend थोड़ा पिन कनेक्ट करते चलिए मिकाइल सोहाग और मासूम
Hello, Sajid, do you hear me?
Yes, I do.
Okay. All right. Okay, I'll continue. What I was saying is the main reason for battery system to have success here is because let's say someone is driving a car, if he doesn't know where to charge it, then he will not feel good to buy a car with a battery system. So the infrastructure is important, and also the dollar cost per mile of compared to gasoline. It is also another important factor for battery system. So these two are a positive side for battery system. That's why the battery powered transport vehicles are picking up. And hydrogen fuel cell has other benefits, but it is lacking on these two. So let's see eventually what happens. But my guess is eventually the battery powered system will dominate the future of transportation. One revolution that is going on is mainly in the industry. I haven't seen much of work in the academia, but I hope that will also pick up, is the IoT revolution and digital twin. The reason is that for an industry, many motors, drives, and full system is now going towards automation. and there are less people working in the industry. So with automation, the problem is if you have no people, then if something goes wrong, then you have to send someone and maintain it, right? So in order to avoid that, you need to have everything connected, and you need to have the real-time monitoring of them. So that is enabled by IoT and digital twin. A digital twin is basically like you have for a particular, let's say for a motor, you do have some sensors mounted on the system, and you, based on those measurements, you basically have an idea of how it is working, and you can project its lifetime, and also you can also because you are monitoring, you know if there is anything going wrong or not. So this IoT connected all these devices, all the data available in the cloud. You can monitor anything you want. You can set flag, alarm system if something, or if some temperature goes above these or vibration goes above these, just let the plant manager know about it. So that way, the digital twin and IoT is helping eventually to have less reduced downtime. Downtime means, let's say one particular motor is down, then a block of the production can be down. So that can be avoided if you have greater visibility on that. So there are some research aspect on that also. Okay, finally the future of energy. Yes, it is renewable because you know what happened in Japan in 2011. One of the power plant exploded, unfortunately, and Japan took lesson, and they are now going towards 100% renewable. It is not done yet, but they are in their way. The reason it takes time because of trillions of dollars already spent on existing system, on existing energy installations. So that has an inertia of at least 50 years or more than 100 years to eventually go to a new technology. And it is happening, and everywhere in the world, all the countries are now going towards renewable. Just to give you an example, right now in United States, to power the whole United States, you just need a 100 miles by 100 miles area of solar energy, which can power the whole United States. So that means we have plenty of energy. We just have to smoothly transition to that renewable. I'm almost at the end of the slide. This is one slide that is some tips for future career. I would suggest to go for a bigger research group, because you not only learn from your professor, you also learn from the whole team, the whole group. Your professor is also very important because he will give you the long-term, and the most important thing is your long-term goal. So you don't expect from him that he will just show you how to do a simulation, or if you are how to design a circuit or whatever. You don't expect that from your professor. The main important thing is because you are deciding of your rest of your career based on his research direction. So the direction is very important. And you will work with many students, many years in the lab. So the bigger the group is, the better it is you learn. And it is after your undergraduate, I would say the undergrad was the toughest, hardest step in your career. The rest of it is very easy. So once you are done with undergrad, just stick with it. You'll be good. The final slide is on motivation. That is, to me, is very important because we always hear that, okay, you just have to go to BUET or go to that university and then you are done. And then you see, oh, no, after that we have to do this. And then we see, no, after that we have to do this. So we need to have a very sustainable motivation to achieve something. So first of all, you need a very strong determination that you want to achieve something. And also you set your day-to-day goals or your short-term goals, make it manageable. Okay? Don't try to be very unrealistic goals. Then it is difficult to achieve and then you get frustrated. And also it has to be challenging. You should feel like you achieved something once you achieve something. And also don't stuck. If you are stuck on something, seek help. There are people, almost everyone I see are actually willing to help. And this today's world of networking and connectivity, you have connection to many people, so you will get help. And the most other important thing is how to keep motivated is some time has to be for you only. You have to recharge yourself. In the weekends, you don't really do research or work all days of week. Some time has to be for your hobby works. Like I do gardening, I do woodwork projects, so that recharges me, and also I spend time with family. And also you should share your success with people, so the people will encourage you, and you'll receive rewards when you share. So all these helps you to keep motivated for a long-term goal. And yep, that's pretty much end of my talk, and I'm open for questions.
Thank you very much, Dr. Rajib Mikail, sir. We have one question from Moshur Rahman Sardar in the chat box. So if you could unmute yourself and introduce yourself and ask the question.
Assalamu alaikum. Thank you for giving me the floor. I want to learn something about battery technology, and also some from renewable energy, like where from we can start to research in renewable energy.
I see. Okay, renewable energy is also one of the highly seeked research topics right now. So what actually people are doing is the the technologies that I have presented in earlier. So if it is for renewable energy, it can be solar, it can be wind, it can be wave, like ocean wave. So for, let's say for if it is solar, then it will be totally power electronics based, because the power that comes from solar inverter, solar panels are electric voltage. We readily get the voltage out of it. So the maximum power tracking system, and also making it like for example, if you have a megawatt scale solar system, then this amount of power, transferring it and connecting it to grid, there is a huge steps in between the solar power and the grid. So there are a few power conversion, like DC to AC, and then AC to AC. So these are different steps that you can work on. If it is wind, or wave where their motions are available, are involved, then you will have generator in between. So for wind case or wave energy case, there will be a generator which will convert the motion, rotary motion, to electrical voltage, like AC voltage. And then from that voltage, which will be ups and down, and depending on the source, the voltage will be fluctuating a lot. So there are research how to convert this hugely fluctuating voltage to a steady voltage to DC, and then from DC to our grid voltage, which is AC. Yeah, so I would suggest study some papers, recent papers in the conferences that are related to renewable energy, and then you will get idea what are right now people are doing.
Okay, sir. Thank you.
Mashir, you didn't introduce yourself. I mean, which institute are you from?
Oh, sorry. I am Moshir Rahman Shordar. I am from United International University, and I am currently studying on IEEE, Electrical and Electronics Engineering Department.
Okay, thank you very much. Next, I have Habibur Rahman. Who asked a question. I would invite him to introduce himself and ask the question. Habibur Rahman.
Assalamu alaikum, sir.
Alaikum assalam.
I am currently graduated from Manarat International University. I would like to know more about in renewable energy, actually in solar system and PV cell, because currently in our country a huge amount of solar system is installing, but they are very low efficiency and their outcome is disaster. So is there anything we can learn or we can research on it?
Yes. The performance of the converter that is used for converting solar power to the level that we need is it totally depends on the power scale. Let's say, for example, if you just power only a home, then it will be, for example, 2 to 4, 5 kilowatt system, and the efficiency of that system will definitely be not good. So the research that I have presented, those are eventually going to help in boosting the efficiency of these low power scale also. However, the efficiency, if it is a larger scale system, like a megawatt scale, then the efficiency is higher. And if that system is connected to, let's say, 100 homes, then everyone can share power from there. So the research I would suggest to if a locality is going to solar, then the business model will be like all of them connected and share power between them. And like when someone doesn't need power, then their battery in their home will be actually contributing power to the other person. So that way, it will be very efficient. But if it is only for one person, one home, then it is difficult to achieve that because you need everything for that home and you are not getting the most out of it.
Thank you, sir, for your kind information.
Thank you very much. Next question is from Shahadat. If you could introduce yourself and ask the question.
Yeah, I think whoever is talking, please unmute because sometimes you forget to unmute.
I think he's unmuted. I don't know. We cannot hear him for some reason. Okay, I guess I can read the question out aloud for him. So his question was, will it be possible to make 100% renewable energy in Bangladesh? And is there any research going on renewable energy in Bangladesh in 2019 to 20?
Okay, yeah, yeah, it is possible. The power need for Bangladesh and the amount of solar energy available from sun is definitely possible. The only thing is it's a huge infrastructure cost, and it will take time for this to eventually happen. The research aspect of it is in Bangladesh. One thing is like depending on the economic feasibility, maybe not all voltage levels are feasible for Bangladesh. For example, if it is a rural area, then converting the voltage, for example, the solar power voltage from DC to high voltage AC, for example, 220 in Bangladesh, that step is, there are costs associated to that. However, if we stay on low voltage, for example, if we have load like fans or lights or TV, whatever, all the devices are now DC powered. So if we just stay with the DC at low voltage DC, then we don't have to do this conversion. So we can save that conversion stage, which we cannot do with any other things. Only renewable energy can let us do that. So that means we have the renewable power at very low voltage, and our loads are also at low voltage. So then it will be very cost effective, and for Bangladesh that will make sense. However, for other countries where this cost associated from low voltage to high voltage is not significant compared to their economic status, then for their cases, maybe they will go for higher voltage and also try to connect to grid or totally connected system. But for Bangladesh, it is possible, and maybe it will be it will make sense to stay at lower voltage, and also like I said, it will depend on the time it will take because of the infrastructure cost and switching from existing system to renewable. It will take some drive for that. Okay.
Thank you very much. We have next Pallab Kumar Moitra. So if you could unmute yourself and ask the question.
Hello.
Hello.
Hello. Can you hear me?
Yes.
Yes.
Yes. Sir, I have seen in our country the neutral connection is omitted from the earth connection. Maximum time in our local area where the distribution connector or technician used the neutral line, they cut the neutral line from the meter. But we realized that if the neutral line connected the proper way from the building system, the earth electron flow turnover from the earth surface to the hollow to the phase pressure turn the electron from earth and the increase the distribution line. But we cannot use the proper electron from the earth, who is increase the electron flow of distribution line. But in our country, the process is totally not controlled in proper way. If this is possible in our country, we think This is increase the electron flow, and the line current will be stable, and balanced system in three-phase line would be possible. Is it a renewable energy process to control the line flow of electron or the distribution process?
Yes, that's a very good question. I have also seen that people sometimes avoid the return path, the neutral path or return path. So that is in high level, it looks like it is working, but it is working at a very low efficiency. The thing is, for renewable energy or whatever the power control device, that device can always measure the current in both lines and make sure that it is connected properly. So in the system design, it has that feature, so it can identify that it is not connected properly, and that is just part of a feature that needs to be added in the system, and that I see that is more like people's awareness. People has to be aware, has to know that this is not right way to wire it or connect it. So awareness is first thing, and the second thing is this protection from the design itself. So even if people doesn't do it right, the system will not allow it to work. Got it?
Okay, thank you very much. Next question is from Jahangir Hossain. If you could unmute yourself and ask the question.
Assalamu alaikum, sir. I am Hossain Jahangir. Currently, I'm doing a bachelor in Tripoli in Malaysia. So I got the FYP2. So I have planned to publish some paper. So just I have the title was my paper Smart Lighting for Highways by Uses of Solar and Wind Hybrid Power System. But I am a bit confused with the energy storage, because we know that the lead acid always cheaper, but they have a very difficult to quite handling. I mean the recycling. So should I use any alternative way to use? Because still now I know that there is still going on the research to just invent the new energy of storage. So I would like to know about this from you. Thank you so much.
Yeah, energy storage is the never-ending problem. Like whenever it comes to renewable energy, you need to have some sort of stored energy, right? So the battery is like initial installation cost is expensive, that's for sure. Luckily, all these costs are going down, and also because of this clean energy effort all worldwide. Now other ideas like hydrogen fuel cell topic is also coming up. So it will be eventually a mix, and also it will be a shared network of power. Like when people, let's say someone is using battery or energy storage in his home or industry, someone is using maybe hydrogen fuel cell. So it doesn't matter as long as energy can be stored. That's what matters. The only thing is the cost of initial investment is relatively higher even at the moment. But if we see the full picture, for example, when someone can sell energy when he doesn't need it, then he will see the benefit out of it. So during the daytime or the time that he's not using energy, he can sell it, and then when needed, he can buy it. So that way, with a bigger system, like when the system will get bigger and bigger, then you will see the overall benefit is higher. But at the beginning, I would say it is difficult to justify for a small scale. And the other topics that people are doing research on energy storage, there are different other topics like flywheel energy storage. Also, there are some sources of like geothermal. That is not a storage, that is like a continuous source. And I also heard about some way of storage like a mini dam. You know about bigger dam where people store water, and then that is like a storage of energy. But for shorter, well, smaller scale is also possible. Yeah. So if your research goal is for energy storage, then I would suggest to work on one particular topic and then go from there.
May I interrupt you a bit?
Sorry?
May I ask you one more question?
Oh, sure.
Sure,
Yeah.
go ahead.
Let's say I have topic, just now I told you, smart lighting. So I'm thinking about the pole, and I try to propose to someone because we want to see the green energy, as well as I wish to be a green citizen of the greener world. So if I want to inspire the people to purchase the electric car because they are worried about to just purchase the car because sometimes the problem with the energy storage and the charging problem. So this is my plan to smart lighting. So anywhere they can charge even the electric motorbike from the pole. So I am to modify this one. I already tried to modify everything. Even they have a surveillance camera to protect the people during of time. And even I have also planned to sell some to advertise from the pole, even though can just taking earning the money. So I'm using here the cloud serving. So my big problem is there now energy storage. So I want to solve this problem because I needed a lot of energy, even though I'm using the LED system all.
Yes, yes. The battery for any renewable system, the battery is true that the storage is expensive. That's true. But I would say in your model when you promote to customers, show them the payback period, that the initial cost of the battery and how long, by what time you will get the payback of the full installation cost. So that sometimes that shows the hope. People will see that, okay, I have to spend this amount of money at the beginning, but I will get it paid by 2 years. So for example, so that will, the business model will help.
So thank you so much.
Thank you very much. And Shahadat actually wrote another question in the chat box. So his microphone isn't working, unfortunately. And he's from Manarat International University. He wanted to know about wind energy future opportunities and research facilities.
Okay, yeah. So for renewable energy sources, there are many sources. Wind is one of them. And we have wind free. We get wind from nature. But the problem is the installation cost of harvesting energy from wind is huge. It is, but once it is installed, then for several years we get energy, like solar also. The thing is, right now the solar panels, the cost of solar panels are going down, and it is going, the trajectory is always going down, which is not like for wind energy system. The cost of the generator and the system that harvest energy from wind is not going down. So then when people wants to, unless there is an area that where you don't have sunlight, it is very difficult to justify wind compared to sun. But if there are areas where you don't have enough sunlight, but you have wind, only then that justifies actually. So it depends on the area.
All right, thank you very much. And actually, I don't see any more questions in the chat box. So if anyone wants to add any last moment questions or comments, please feel free to ask. I can see some of our alumni from abroad also joined the session. I can see Parvez, who was a former graduate from our department, now currently in US. Any other questions or comments if anyone wants to share? Jahangir actually wants to ask another question too. So please go ahead.
Sorry for interrupting again. I have the one confusion. I just talked to my supervisor. I have planned to do some research, but I don't have proper tools to do it. Just I'm thinking about, let's say at Highway Road, I'm thinking about Malaysian causal link between Malaysia and Singapore. So they have a lot of cars moving over there. And I'm feeling when there are car moving, the air pressure, air so is rushy, the air particle is where just the pollution of the another air particle that time would help to rotate the window, wind turbine, I mean. So how this effect will on the wind turbine, as this is my imagination, but I don't have anything to do, still the tool to experiment this. Just I represent my professor, but he doesn't want to do because no have any more tools, so not willing to do it. So he want to ignore this one. So my imagination, how can work? How can I make this thing?
I'm sorry, I could not understand the question very well. Is it like you are trying to harvest energy from the wind from car?
No, I mean in the causal link, when car is moving, they will against of the air. So air particle will collision the another air particle. Then they will help to make the air more rushy and will assist to rotate the wind turbine. Because I'm using the small wind turbine for 12 volt only, DC volt.
Oh yeah, that's what I understood.
I mean this idea will work.
Yeah, the thing is you are trying to get the energy from the when the car is moving, right? So in the car, there are when the car speed is gasoline, then it is taking power from the oil or gas. So and that energy is spent to go through the air. Okay, so depending on the fluid dynamics of the car, the aerodynamic performance of the car depends on the design of the car.
Yes.
So the energy required to go through the air fluid, air is like a fluid, so it depends on the like that particular design, that how much energy will be needed. Now, if you are trying to get energy from that wind, then that will work against that energy source. So that means, for example, if you get 10 watt of power from this wind, you will probably have to spend like more than 10 watt, like let's say 12 watt of power from your gas. So eventually it will come from your gas. That's why even if it looks like this wind is free, but it is not free. It is coming from the gas that you are burning.
Sir, thank you so much.
Thank you very much. Devashish Mondal, you have the question. Go ahead.
Yes, sir. Sir, thank you very much for your beautiful presentation. My name is Devesh Mondal. I'm basically 07 batch of WET. I've been working in Energy Pack since 2013 in transformer production. I have experience of up to 300 MVA transformer production with system voltage up to 230 kV. Sir, I have two questions. That is basically, you can say, very personal question, because I have applied for my visa in Australia in last September, and expecting to get the visa very soon. It's a temporary residency visa, sir. And my question is, as I have been working in transformer engineering, how should I prepare myself to get a job in Australia? And my second question is there any certification required to get a job in renewable field in Australia? That's all, sir. Thank you.
Yeah, first of all, you need to talk to people, those who are in Australia, find someone, friend or friend of friend who are there. They will better know about that. And the certification is, right now, there are lots of opportunities, online courses, which are free or some of them are paid. I would suggest you have lots of experience, use this knowledge to, you can use your knowledge to take one few of these courses which are available online. And after that, you should receive certificate based on that. So the renewable, if it is renewable or transformer, like whatever the subject that you are interested in, there should be courses based on that. And that certificate should be the proof that you are expert on this. And I hope that will also help. First of all, your expertise that you spent time on these transformers, that is the first thing that people should see, your experience, the time that you spent on it. And then definitely there will be some certificates that will be helpful.
That means, sir, you are suggesting that as I have been working in transformer engineering, so I should get some certificate that's one transformer engineering.
Yeah, if any entity online, any university which is online, they can provide you their training or course related to your field, like transformer. And then I don't know if you have to find it actually, if there is any certification process that can show that you have this experience. Otherwise, also someone expert in your company who, let's say, who are more experienced than you, take a reference letter from him that you had spent this much time and you have these experiences. So these reference letters also sometimes help in the job.
Okay, sir. Thank you very much, sir.
Thank you very much. And I just wanted to add, you must know Dr. Nahid Al Masood and Dr. Shamim Reza. So both of them did their PhD in Australia. So maybe talk to them and they might be also be able to give you more specific guideline regarding Australia if you need.
Okay, sir. Thank you very much.
Welcome. We have another question from Nazia Zannat. If you could introduce yourself and ask the question.
Hello, everyone. Can you hear me?
Yes.
Okay. I actually joined the meeting late. I'm sorry if you already have covered this topic. My question is, how long is the battery life for this renewable energy systems, and how difficult is it to dispose the batteries? Thank you.
Okay. Yeah, that's a very good question. Battery recycling and battery disposal is another issue that needs to be solved, which is not a big problem yet, because we have not used a lot of battery yet. But eventually, when everything will go for renewable, then the battery will be a problem. So I think there should be a recycling mechanism because the material that is needed to make battery, that is also rare, and it is not just free from nature. So that means we have to recycle it. So whenever there will be a recycling mechanism, and when we will be using battery in large scale, then the recycling will help. So we don't throw it to the nature and make trouble. Yeah, and another question was the lifetime. The lifetime is yeah, that is also another issue for battery, that it doesn't last long. What I know so far is 5 years is the average, and there are research going on this, and hopefully 10 years we'll see battery technologies which will last more than 10 years without much of an issue. And also it depends on the cycle use. The more it is used, the faster it will degrade. So yeah, that is another aspect that of the life.
Okay, thank you, sir. And so it turns out that and there would be a, I mean, balance that if I install these things, say on my house, it has to be cost effective, at least how much energy I would use in 5 years and how much energy that could produce, right?
Yes, so
So
right now there are
that cost
companies.
effective right now, the technology is there nowadays, and how much savings they can do, considering all the installation costs.
Yeah, so that's another business model, that those who install the battery system, the like energy system, they show that right now they show that this is the initial cost and this is the payback period, and also some of them are promoting like in a way that you don't have to pay anything. They will take care of everything. They will install it. You just pay your regular electric bills like before, but the payment that you are paying, some of them actually goes to them because they have installed it. So the motivation is the payment that you are paying. If it is lower than your current bill, then only it matters. So I guess the solar energy system, full system installation right now is in a level that we don't have to pay more.
Okay, thank you, sir.
Thank you very much. Is there any more questions or comments from the audience? If not, let me quickly share my screen for a bit. So I actually, excuse me, I actually have a, sorry, let me figure out, not share, computers not share. Okay, I actually have a speaker certificate for Dr. Rajib Mikail for sharing a wonderful presentation and answering all the relevant questions from everyone. So this is a virtual token of appreciation from us, the IEEE Young Professionals Bangladesh. And hopefully we also thank all the participants who came today. Hopefully you would be continue to come to our events and network with the young senior young professional members of the IEEE Bangladesh section. So with this, I would like to thank the speaker again, and I would like to conclude this session. So thank you so much for joining with us today.
Thank you. Yeah, thank you for arranging this. Talk to you later, everyone. Bye.
Thank you. Bye.
Thank you, everyone.